Now the next question arises here. Okay, we came to know about organic chemistry. We came to know the source and the history of the organic compound, so to say. Now the next question arises, why do we require a new branch of chemistry? That's organic chemistry. Because already we are having existing two, that is physical chemistry and your what you can say inorganic chemistry. Why do we require a new branch of chemistry that's said to be as organic chemistry, which we are knowing it today? The reason is there are huge differences, large differences, alright, between the organic and the inorganic compounds. We can say that. Where inorganic compounds is merely 90,000 and organic compounds, you know how much it is? It is more than 5 millions. More than 5 million, that is more than 50 lakhs of organic compounds. Out of that, 90% is artificially prepared in the lab. It is artificially synthesized. 90%, more than 90% of it the compound. Alright. So hence, where inorganic compounds are merely 90,000, organic compounds are more than 50 lakhs, more than 5 millions. And every day some or other compound is being added to the list. So the first point is that it is large number. Organic compound are of large number, huge. So we can say that the mother of the science, not chemistry, I'll say, mother of science is your organic chemistry. Alright, without the knowledge of organic chemistry, it's not possible. Science is not possible. Today's life is not possible. It's very simple, I can say that. Today, see, I am teaching to you online, isn't it? How? By the help of mobile or by the help of net and all those things. What is the handset of mobile made of? Polymers, plastics, organic chemistry. It's a branch of organic chemistry. Your laptop, your desktop, alright, the screen, the laptop screen or the cabinet of the laptop or the desktop, what it's made up of? Again same thing, polymers, plastic, organic chemistry. Alright, you wake up in the morning, the first thing what you do is that you brush your teeth, isn't it? You use a toothbrush, what is that? That is nothing but again plastic, polymers, organic chemistry. After that you take your tiffin, let us say you are taking, that is your bread, you are taking jam, jellies, butter and all these things. Bread is made up of what? Yeast. We are adding yeast to the flour. We are adding it. Yeast is what? Again the organic compound. In the jams, jellies and butter, we are adding the sodium benzoate, which acts as a preservative, organic compound. The clothes which you are wearing it, mostly they are the synthetic clothes, again organic compounds. So you go on making the list. Right from the morning to the end of the day, you will see the knowledge of organic chemistry is being used in one way or the other. The house is built by the help of what? Cement. Again organic chemistry. Paint is being used. Nowadays you know that we are using the red oxide. Red oxide is what? Again it's an organic compound. It's the knowledge of organic chemistry. Alright, so in this way, in one way or the other, organic chemistry is used in our day-to-day life. Without that it's not possible. It's not at all possible, we can say that. Life is not possible. Now in the lockdown it is not at all possible. Alright, for that particular purpose, organic chemistry is large number compared to inorganic compounds. We can say that. First point. Second point is that they are complex in nature. Organic compounds are complex. Even if organic compounds basically consist of carbon and hydrogen and few other elements are attached to it like oxygen, nitrogen, sulfur, phosphorus and all these things. But still then organic compounds are complex in nature. They are not simple. Like inorganic compounds like sodium chloride, like sodium sulfate, potassium nitrate, ammonium chloride and all. They are very simple compounds. Alright, they have got simple methods of preparations. But you'll find now here, you'll see it when you'll study the preparation of organic compounds like alkane, alkene, alkyne, alcohol, aldehyde, ketones, ethers, alright, carboxylic acids and so many you'll be studying it. You'll be seeing that it has got a complex method, different methods of preparation. It's not a simple method. So hence it is complex in nature. Alright. Now, next is after that you will find it out that mostly they are covalent molecule. Which one? Organic compounds. Mostly what? All are covalent molecule. But inorganic compounds may be ionic, may be covalent. Sodium chloride is an ionic compound, but carbon dioxide is covalent. Yeah, one more question comes here. That carbon dioxide is also a compound of what you can say of carbon only. Like carbon dioxide, calcium carbonate, then you can say what more we can have, calcium bicarbonate, Clear? So they are, why it is considered to be as an inorganic compounds? Why not organic? Because even if carbon is present as one of the constituent element in carbon dioxide, carbon monoxide, calcium bicarbonate or calcium carbonate, even if carbon is being present, but their behavior, their nature, their properties is completely different from organic compounds. So hence they are not included in the branch of organic chemistry, even if carbon is one of the constituent there. They are included in organic chemistry. Alright. So organic compounds are mostly covalent in nature. They are not ionic, not at all. They are covalent. They are being formed. The organic compounds are formed by the, not by the transfer of electrons, but by the sharing of electron pairs. We can say that. Clear? More of the bond about, you will be studying it in the bonding chapter. Next is, after that, these compounds have low melting and boiling point. Low melting and boiling point. Because covalent compounds are generally liquids and gases. They are generally liquids and gases, and organic compounds are mostly liquids and gases. And hence, they have got low melting and boiling point for that particular purpose, because it matches with the properties of the covalent compound. We can say that. Ionic compound, they are joined together by strong electrostatic force of attraction. Ionic compounds. So hence, they have got high melting and boiling point. Sodium chloride, sodium ions and chloride ions are held together by strong electrostatic force of attractions. Hence, they have got high melting and boiling point. But organic compound, no. They are held together by covalent bonds. Alright, hence they have got low melting and boiling point. And due to that reason only, as they are covalent, they are insoluble in water, or I should say polar solvent. Water is, you know that it's a polar solvent. Water is. Polar means what? What do you mean by the word polar? Polar means which has got two poles. Positive poles and negative poles. How? Hydrogen, HOH. Isn't it? Water can be written in this way. In organic chemistry, you will see I'll be writing water as HOH. Lot of things you learn it now. Lot of things. It is written as HOH, where H is positive and OH is negative. That's it. So hence it is polar. We can say that. The compound which has got poles, even if it is covalent, but it is having positive and negative poles. So hence it is said to be polar. So hence water is considered to be as a polar compound. Not only this much. Polar means, it does not mean this. Just in easy language I have explained you. When you will be studying about the polar compounds, you will be seeing that a lot of more things will be coming. Alright. Lot of more concept you will be studying about it. So just in easy language, got it, to a layman, if I want to make you understand that what is polar, that is what I said. Polar means polar, means two poles. What poles? Positive poles, negative poles. How? See, I have shown it to you. Alright. Why? What I said you, it is insoluble in water, but soluble in organic solvent. Organic compounds are soluble in organic solvent. Organic solvents are non-polar in nature. Which one is organic solvent? Diesel, petrol, kerosene, alcohol, benzene, toluene, they are said to be as organic solvents. Chloroform, got it? So they are organic solvent. In organic solvents, they are being soluble. Which one? That is organic compounds. We can say that. Clear. Next is, what you find is that they show isomerism. Just now I told you, I gave the example. Isomerism, organic compounds. This phenomena we don't have in inorganic compounds. We don't have. Alright, for example, see here, one more example of isomerism I will give you. Like we are having a molecular formula C2H6O, isn't it? C2H6O. It can be written as C2H5OH, and it can also be written as CH3OCH3. See here, C2H6O. Here also C2H6O. So it is what? It is ethyl alcohol. It is an alcohol. How do I come to know? From this functional group, that is OH. And this is what? This is ether. What ether? Dimethyl ether. Dimethyl, because 2-methyl is there. Dimethyl ether. The functional group is single bond O single bond. Whose functional group? This one is ether. Now I am using a word here, functional group. Next is also the same thing. This functional group properties. Functional group properties you will find only in which compound? Organic compounds. Are we having any functional group in inorganic compounds? Have we studied anything? Can inorganic compound be written in this way? For example, H2SO4. Can I write in any other way so that it will be two different compounds? Like here C2H6O, I arrange in two different manners. It has got two different structure. We can say that. This is a molecular formula, isn't it? This is a molecular formula. And these two are the structural formula. They have two different structures. Now H2SO4, can I arrange in two different structures? NaCl, can I arrange in two different structures? Potassium nitrate, can I do it in two different structures? Ammonium chloride, can I do in two different structures? No, not at all, not possible, because they are inorganic compounds. They do not show the phenomena of isomerism, but organic compound does. You are having a chapter on isomers and isomerism. We'll be studying here only in class 11. At that time, you'll know that how different types of isomers we are having it. So, organic compound shows the phenomena of isomerism. Inorganic compound does not. Functional group properties. This is functional group, which determines the chemical properties of a compound. How do you know it is alcohol? Because from the functional group that is OH. From the functional group that is OH, functional group determines the chemical properties of a compound, which is the characteristic phenomena of organic compounds only. We don't find functional group in inorganic compounds. Here also same thing. The functional group is single bond or single bond. Got it? In this way, what you find is that they are poor conductor of heat and electricity. They do not conduct because they are not soluble in water. They are not soluble in water. They do not dissociate into its ions. So how they will conduct heat and how they will conduct electricity. Alright. So in this way, what you find is that they are showing the molecular reactions. If you see the chemical reaction, they show only molecular reactions. They also show the phenomena of catenation. Alright, catenation. Catenation, what I said? Catenation, they show the phenomena of. In this way, many are there. We can write so many points. It's not just 7, 8, 9, 10 points. We can write so many points. So catenation. Catenation is a unique property of carbon atom to combine with itself and also with other elements to form a long chain of compounds. Again I repeat, catenation is the unique property of the carbon atom. It's a unique property of the carbon atom to combine with itself, like carbon can combine with carbon, so many other carbon. Alright, it can combine in this way. It's a unique property of the carbon atom combined with itself and also with other elements, like in between you can see oxygen is coming. With other elements like oxygen it can come in between, sulfur it can come, nitrogen it can come. Alright, so again I repeat, catenation is the unique property of the carbon atom, only for the carbon atom. Alright, carbon atom shows. Why? I'll come to it later on. It's a unique property of the carbon atom to combine with itself and also with other elements like oxygen, nitrogen, sulfur, chlorine in this way to form a long chain of compounds or a branched compounds are known as, what you can say, catenation. This is known as catenation. It's a peculiar phenomena, it's a peculiar characteristics of the carbon atom, we can say that. So all these particular things you can find in organic compound. Do you find in inorganic compounds all these things? No. So this differentiates organic to inorganic compounds. And how can you keep the inorganic compounds in the branch of organic, or how can you keep the organic in the branch of inorganic? Because it has completely different set of properties. Completely, we can say that. So hence we require a new branch of chemistry called organic chemistry, or it may come in your exams. So what is the difference between organic and inorganic chemistry? You can write these points. We can say that. Thank you very much.